Hello and welcome to another one of these ADD videos. Today we're going to be looking at calculating KCs and also calculating equilibrium concentrations depending on what you're given. First, let's look at calculating KC. If you are calculating KC and you are given your equilibrium concentrations, if they're that nice to you, remember that your Kc is a ratio of the products to reactants with the coefficients being the exponents over here, excuse me. So in that scenario, you literally just have to plug in your concentrations if they were nice to give it to you in terms of molarity. If they give it to you in terms of moles and liters, just remember molarity is nothing more than moles over liters. Or if they give you grams, convert to moles. How do you convert to moles? Just take the grams divided by the molar mass. Okay? That would be too nice of them to give you a problem like that. More likely they'll give you something like this for calculating Kc, in which you are given a reaction, some initial concentrations, and a change. So basically what you want to do is you want to set up a Rice table. Rice stands for reaction, initial, change, equilibrium. And if we were given these initial concentrations of the reactants and this change, you would subtract to get the equilibrium concentrations. Now, a couple things to note. One, the change is always a minus for the reactants. We're taking away from the reactants and we're adding on the products. Also, if there's a coefficient of your chemical equation, there should be a coefficient in your change. Okay? And then all you do after that is you take that and you plug into your Kc. I guess I never wrote a Kc for this one, so in this case the Kc would be the products of reactants, so something like this. Right? And then you would plug in these values, so it would be 0.1 squared, 0.015. Actually, it should be 0.15. I can catch that. Sorry about that. I guess I should miss that too. I'm human, we all make mistakes, right? That's why it's a good idea to check your work, always. Alright, so if you plug that into your calculator, you get your Kc. Now, let's say you knew your Kc. What can you do then? Well, again, Rice tables. What is unknown now is the change. You don't know the change. But the concept's the same. Still put minus signs for the reactants. Coefficients come down. Now you get this number minus x, whatever that initial concentration is, and then 2x here. You would plug into your Kc equation. That would look something like this now. Let's do a different color. Kc equals 2x, in this case squared, right, over the number minus x times the number minus x. What you can do is you can say two like bases multiplied is the same thing as the like base squared, and then at this point that equals Kc, so you can square root both sides and you get some new number for Kc, and the left side becomes a little bit more manageable because the square roots negates the square. Kc, whatever that new number was, and then you would multiply that over there, get the x's on one side, and you might need to practice your quadratic formula. Alright, those of you that it's been a while since you've taken a math class. I'll write that for you. So x equals the opposite of b plus or minus the square root of b squared minus 4ac. I'm sorry to those of you that are having flashbacks of high school or bad math teachers, bad brothers, sisters, or parents that force you to hate math. Math is a beautiful thing, and it's the language of all the universe. But that's not what we're talking about now. We're talking about KCs. Another nice little tip is if your KC value is 10 to the 5 or less, you can you can ignore the minus x, because what that means is there's such little dissociation. If you remember the K values, when they're very small, it's mostly reactants, right? Little of the reaction went forward. Well, what that means is that change is so small, and compared to the initial concentration, that change is negligible, and that number is much greater than the x, so we can ignore it. It's not going to affect anything, all right? And it makes your calculations much easier. So that's basically the concept for dealing with these calculations. Get familiar with these rice tables, and practice, practice, practice is definitely the key to these, all right? So check out the example videos, and thank you, and have a nice day.